In this video, we will discuss about the mathematical induction. First, principle of mathematical induction statement. Let P of n be a statement involving the natural number n. Then, number 1, to prove P of n is true, this step name is basis step. Second one, assume P of k is true, and to prove P of k plus 1 is true, then we conclude that a statement P of n is true for all natural numbers n. This step name is inductive step. Now one example. Prove by principle of mathematical induction for n is a positive integer 1 squared plus 2 squared plus 3 squared up to n squared equal to n into n plus 1 into 2n plus 1 divided by 6. Then proof. First we take the given statement P of n is 1 squared plus 2 squared plus 3 squared up to n squared equal to n into n plus 1 into 2n plus 1 divided by 6, which is equation number 1. Now we use the principle of mathematical induction, step 1 basis step, to prove P of 1 is true. That is, put n equal to 1 in equation number 1. Then P of 1 is in LHS 1 squared equal to 1 into 1 plus 1 into 2 into 1 plus 1 divided by 6. Here LHS 1 squared, that is 1. Then RHS 1 into 1 plus 1 into 2 times 1 plus 1, which is 6 divided by 6. Therefore RHS 6 by 6, answer is 1. Here LHS equal to RHS, that is 1 equal to 1. Therefore P of 1 is true. Then second step, inductive step. Assume P of k is true. That is, put n equal to k in equation number 1. Then P of k is 1 squared plus 2 squared plus 3 squared up to k squared equal to k into k plus 1 into 2k plus 1 divided by 6, which is equation number 2. Now to prove P of k plus 1 is true, therefore put n equal to k plus 1 in equation number 1. That is, P of k plus 1 is 1 squared plus 2 squared plus 3 squared up to k squared plus k plus 1 whole squared equal to k plus 1 into k plus 2 into 2k plus 3 divided by 6. Now take the LHS term, that is 1 squared plus 2 squared plus 3 squared up to k squared plus k plus 1 whole squared. Here 1 squared to k squared value is k into k plus 1 into 2k plus 1 divided by 6, which is equation number 2. Then we use the equation number 2 up to k squared value. Answer is k into k plus 1 into 2k plus 1 divided by 6 plus k plus 1 whole square. Now take the LCM 6. Therefore k into k plus 1 into 2k plus 1 plus 6 times k plus 1 whole square divided by 6. In numerator, k plus 1 is a common term. Therefore we take k plus 1 is common. Then the remaining term is k into 2k plus 1 plus 6 times k plus 1 divided by 6. Therefore the first term k plus 1, the second term we multiply, we get the result is 2k square plus k into 6k plus 6 divided by 6. Therefore the first term as it is, that is k plus 1. The second term simplify, then the result is 2k squared plus 7k plus 6 divided by 6. Now the second term is the quadratic term, quadratic equation. Therefore factorize this equation, we get the result is k plus 2 into 2k plus 3 into first term k plus 1. Therefore the answer is k plus 1 into k plus 2 into 2k plus 3 divided by 6, which is equation number, which is the RHS of P of k plus 1. Therefore P of k plus 1 is true. Therefore by mathematical induction P of n is true.